buy a large soda, 3y, equals $22.50. So then for the second week, it was they spent, they each got a large drink, but they shared a large popcorn, and each one of them paid $8 this time. So I have 3x plus y equals, they paid a $37.50 minus the $24 that it cost them each to get in. So then, just so I can do that a little quicker, I end up with having to multiply this by a negative number so I can get them to cancel out. I get 3x plus 3y equals $22.50. A negative 3x minus y, and it ended up equaling at $13.50, negative $13.50. So now when I add my two and I use the elimination method, I end up with 2y equals, what did I get 2y to equal? 2y ends up equaling 9, dividing by 2, so I know that y equals 450, which is my popcorn. So I'm just going to write it down here. My popcorn equals 450. And then when I plugged it back in, not going to go through the whole process, but I ended up getting that my drink cost $3. So the reason I can write in part B is that part B said, did you write two equations? And yes, I did. So I can actually just skip part B. Okay. Problem number 221 says, plot each pair of points and find the distance between them. Give answers in both square root form and as a decimal approximation. So I'm just going to write out the answers for this one. I'm not going to show all my work. But for A, I knew that the y's were 11 apart and the x's were 5 apart. So I just did 5 squared plus 11 squared equals c squared. When I figured that out, I ended up with the square root of 146, which is about 12.1. For B, I found they were 9 apart for one of the points and 8 for the other. So I ended up with the square root of 145, which equals about 12. So several people got the square roots but didn't do the approximation, so it ended up being wrong. This one, they're 5 apart for both points, actually. So you end up getting the square root of 50, which is approximately 7.1. So make sure you have both the square root and the decimal. Then it says, write the distance you found in part C in a simplified square root form. So I'm taking the square root of 50, and what I'm really trying to do to it is figure out what square roots are perfect squares that I can multiply together to get 50. So I know that I can find the square root of 25 times the square root of 2. So then I just say it's 5 times the square root of 2, and that's my final answer. Problem 22 says the amount of profit in millions made by Scandal Math, a company that writes math problems based on tabloids. Articles can be found by this equation. P of n equals negative n squared plus 10n, where n is the number of textbooks sold in millions. Find the maximum profit. So I graphed this equation, and then I just looked for my vertex, and it turned out the vertex was 525. Which means that n is equal to 5. It says find the maximum profit, 5 million, and the maximum profit would be 25. Problem 23, it says our friend is taking algebra and is at a different school where they're not allowed to use graphing calculators, and wants us to explain to her how to graph the function in y equals 2 groups of x plus 3 to the second power minus 8 without using a calculator and without making an xy table. So what you needed to explain to her that you'd said whether the parabola should open up or down and how the shape is related to the shape of y equals x squared. So first we could say I know the vertex is going to be negative 3, negative 8. Okay, because it's within the equation. I know it's going to open up, and it's got a stretch of 2, which is going to make it skinnier. Then it says, your friend also needs to know how to find the x and y intercepts. Show how to find them without having to draw an accurate graph or using a graphing calculator. So to find the y-intercept, we just plug in, we're just going to replace 0 with the x in the graph, and it ends up being -8. So the y-intercept is 0, -8. And to find the x-intercepts, we just set them equal to y. So we would do 0 equals 2 groups of x plus 3 squared minus 8. So we'd add 8 to both sides. So we get 8 equals 2 groups of x plus 3 squared, divide by 2. So we end up getting 4. So 4 equals x plus 3 squared. Now we can use our square root property. We get plus or minus 2 equals x plus 3. So subtract 3. So now I have -3 plus 2, or -3 minus 2. So I know my intercepts are -1, 0, or -5, 0. Problem 24 says, consider the equation y equals 3 groups of x minus 1 squared minus 5 and y equals 3x squared minus 6x minus 2. So it says, verify that they are equivalent by creating a table or a graph. I created a table. You would create the graph on either in Desmos or on your graphing calculator. So I did 2 tables. One for, let's call this graph A, and this one B. So here's my table for A. And then for B, I did the same thing. So I created a table. I did, let's just do a few points. -1 I found out was 7. 0 was -2. 1 was -5. So I used the same points for the equation B, and I plugged them in, and I get the same exact values. So you needed to show that you were going to get the same exact values. Then for part B, it says show algebraically. So I chose to multiply out the graphing form because I thought that would be the easier way to do it. But you could factor the other one as well. So first I multiplied it out, so I got 3 groups. I know that this is going to be x squared plus, it's actually -2x plus 1 minus 5. I have to multiply everything by 3. I get 3x squared minus 6x plus 3 minus 5. So then I get 3x squared minus 6x minus 2, which is the same equation as the other one in the problem. Then problem C says, notice that the value of A is 3 in both forms of the equation. It wants us to explain why we think that's true. And that one of the reasons I thought it was true is that A ends up being the coefficient of x squared after the binomial is squared. So either way, in either format, we can pull out a 3 in either problem. So like I can divide everything by 3, which is one of the first things I do. So I would say in both forms, A would be the same because it gets factored out. Okay. Problem 225 says, use what you learned in the parabola investigation to write an equation for each of the parabolas described below. So one of the things that we talked about when we were doing the parabola investigation is the formula, where I have a x minus h to the second power plus k, where h right here is the opposite of whatever it is. So it says a parabola opening upward. It doesn't tell me anything about my stretch factor. So a is actually going to be 1. shifted 8 units to the right and 5 units down. So when I do this, I want to be able to move 8 right. So I want to make it a minus 8 so that when in my vertex it's positive 8 squared, and then 5 down is going to make it a negative 5. So my equation should be x minus 8 to the second power minus 5. B, a parabola with a stretch factor of 10. That means that my 10 is going to go outside my parenthesis, and sitting with its vertex on the x-axis at negative 6. So I know I want to do x plus 6. And then I'm not going to add or subtract anything because I'm on the x-axis, so I want it to be 0. And then the C says a downward opening parabola, so I know it's going to be negative, with a compression of 0.6, so it's negative 0.6 goes outside. The vertex, so I do x plus 7 squared minus 2, because in the parentheses, remember it's always going to be its opposite. Okay, problem 27. We want to practice changing radicals into their more simplified expression by removing any perfect squares. So 50 we actually already did earlier. So I know that the square root of 25 times the square root of 2 is going to give me the square root of 50. So I just rewrite it as 5, the square root of 2. So in 72, I know 9 is a multiple, and 8 has a 4 in it. So when I rewrite it as more than a couple different things. I know that I can do 4 times the square root of 2 times the square root of 9. If I do 4 times 2 times 9, I get 72. But 4 and 9 are perfect squares. So now I get 2 times 3 times the square root of 2, or 6 the square root of 2. The last one is 45. I can do 9 times 5. So I do the square root of 9 times the square root of 5. So I get 3 the square root of 5. Problem number 28, find the value of x. At first I thought we were going to use SOHCAHTOA and use my triangle trigonometry, but they're not right triangles, so I actually have to use the law of sines. So for the first one, the first thing I have to do is figure out what this angle is. It turns out it's 110. I'm going to write that a little bit better. Equals 110. So when I do this, I have to figure out that using the law of sine. So I know that the sine of 20 over 17, because that's the side across from the 20, is equal to the sine of 110 over x, because x is directly across from 110. So in order to do this, I then need to cross multiply. So I get x, the sine of 20, equals 17, the sine of 110. Divide both sides by the sine of 20. So then when I do that, I get x by itself, and x ends up equaling 46.71 approximately. So then, for this one, again, I have to find the missing angle. So it turns out the missing angle is 89. So now when I write it as my sine, so I have the sine of 89 over 10 equals the sine of 55 over x. Same thing, I'm going to cross multiply. I'm going to get x, the sine of 89, equals 10, the sine of 55. Divide both sides by sine of 89. When I do that, x ends up being approximately 8.19. Now the last problem, we actually did this problem in a math notes already. It says, suppose your parents spend an average of $300 each month for food. In 5 years, when you're living on your own, how much will you be spending on food each month if you're eating about the same amount? So we can actually put this in the formula. So I know if 300 is my initial amount, 4%, so it's 1.04 because inflation, to the 5th power. So it ends up equaling about $365. Then it says write an equation. So we basically just change my 5 into an n or an x. So my equation can look just like that.